Let's have a discussion on the constructional details of an MCB or a miniature circuit breaker. It works on two major principles. One is during a short circuit fault, two is during an overloading condition of the circuit. In both cases, a miniature circuit breaker trips the circuit. For that, it has two arrangements. One is an inductor connected in series with the circuit so that the entire current can flow through it. Another is a bimetallic thermo element that is also connected in series with the circuit. When any short circuit arises, the current crosses a threshold value, the magnetizing force of the coil becomes so high that it will be able to move the plunger, which will strike the tripping mechanism lever to trip the circuit breaker, or MCB. The other arrangement is the bimetallic strip, which bends during overheating. That means during overloading condition. When it bends, it pushes the mechanism to trip the breaker. Now let us explain with the image. This is the external connection of one side. This is the external connection of the other side. During switch on condition, current starts flowing through this part. This is the fixed contact, and this is the moving contact. From this connection, current flows to the coil. Then from this coil, it flows through the bimetallic strip and finally comes out from the external terminal. Now suppose, for any reason, we want to switch off the circuit manually. We can do it by operating the handle. When we pull down the switch, it rotates. Accordingly, the moving contact detaches from the fixed contact, breaking the circuit. That is manual operation. Now, if there is an overloading condition, the current beyond the limit flows through this path and the bimetallic strip. Due to high current, the strip heats up and bends. It pushes this point, and as soon as it does, this spring-loaded lever is released. The mechanism rotates and the moving contact moves away from the fixed contact, breaking the circuit under overloading. Now suppose a short circuit occurs. The current in the circuit suddenly becomes very high. When normal current flows through the coil, it produces a magnetizing effect. But it is not sufficient to move the plunger. When the current exceeds the limit, the magnetic force increases sharply. The plunger moves down, pushes the mechanism, and releases the spring-loaded lever. The mechanism rotates, moving the contact away from the fixed contact, breaking the circuit during a short circuit fault. These are the arc splitters. When an arc forms during contact separation, due to the special shape of the contacts, the arc moves towards the splitter, gets divided, and extinguishes. Now see the tripping arrangement for short circuit faults. This is the tripping coil. It is connected in series with the circuit. So this mechanism is called a series trip mechanism, and this coil is called a series trip coil. It has several advantages. Since the coil is powered by the main circuit, the chance of failure is less than with a shunt trip coil. In shunt trip coils, external power is required. If that power fails, tripping may not occur. But in series trip, this does not happen. A shunt trip mechanism needs a separate supply and current transformers, and these make the system complex and requires more space. But in series trip, the arrangement is inside the circuit breaker. However, this arrangement cannot be used in high voltage or high rated breakers, because in that case, the coil size would need to be very large, increasing the overall size of the breaker, which is not practical or economical. So series trip is suitable only for low voltage circuit breakers. Hope you got the idea of the trip mechanism. In the next video, we will discuss the difference between series trip and shunt trip.
If you found this helpful, don't forget to subscribe, like, and tap the notification bell. Got questions or want us to cover a specific topic? Leave a comment. Thank you.